In last two lectures, we have seen what is building management system. Okay. Now, in this lecture, we will start from the end. Okay. In this lecture, we will see the temperature sensors. Okay. So, building management system come to know the things, the temperature, humidity, pressure, light, all those things through sensors. Now we are going to see all the types of sensors. First is temperature sensor, which is widely used in building management system. Okay, BMS we call it, which controls air conditioning or heating, HVAC we call it. Let us see what is temperature sensor. Okay, so first is, which is very famous, thermometer. Whenever you visit to a doctor, first thing he brings out, what? Thermometer. Okay, to check your body temperature. How it works? Simple. Has a tube and a bulb. Okay, at the last. In this bulb, what is there? First is, what did we learn in our 7th standard? Okay, mercury. But there is another element which is used, which is alcohol. So whenever we heat this bulb, the alcohol or mercury will expand and it will go up. Now, as per temperature, it is calibrated. Okay, some standard thing is taken and across which it will be calibrated. Okay, and that is how these thermometers are. Now, next thing, see, we cannot use thermometers everywhere. Wherever there is high temperature, let's say 1000 degrees, our thermometer will burst. Okay, so that is why another things or temperature sensors are developed. So second is thermocouple. Now what is thermocouple, you will ask me? Thermo means heat. Okay. So thermo means heat, thermal energy. So this energy is given to a junction. These are two metals, 1 and 2. Okay. So these metals are connected here and heat is given. Okay. So what will happen? And here voltmeter is provided. So now if we hit this junction, what will happen? See, one metal will have less conductivity, okay, and another metal will have high conductivity. These two types of metals are junction, and these two types of meter are heated at the junction. Now what will happen? Wherever there is high conductivity of the metal, the electrons will move this side. It will be crowded. Okay. And here at the other metal, if it is heated, less electron will travel. You know what is voltage? Voltage is a amount of electrons. Okay. Or we call it potential or potential difference. Okay. Now, the metal which has high conductivity will have high electrons, and definitely the potential difference, number of electrons will be more. And we have a device which will measure the number of electrons, that is voltmeter. So we will see some 0.01 or 0.012 volt in this voltmeter. Okay, and that is how we will be able to find the temperature. Now this voltage is converted into temperature. That we will see later, how this voltage is getting converted into temperature. That is then calibrated with the standard meters. So if heat is more, the voltage will be more, obviously. If heat is less, voltage will be less, definitely. So more heat, more temperature, more voltage. And we will see the number, this number will be converted into the temperature. Okay, that we will see later, how it gets converted. That is called protocols. Okay, I just briefly touched upon backnet protocol and Modbus protocols. So we will see how those protocols are developed. Okay, now you got to know how this thermocouple works. Okay, now third type of sensor is RTD, resistance temperature detector. Okay, this is used for very high range. We will see the range of these sensors. We will see. Okay, now how it works, that is important. This is a probe. Okay, this probe will sense the heat and will determine the temperature, and we will have a display here, how much is the temperature. For very high heat applications, these thermometers or RTDs are used. Okay, now how it is constructed, we say, let us see, this is a ceramic plate. Okay, and then we are just putting a wire on it, and this wire is platinum. Now you will ask me, sir, why platinum? Because platinum has the constant temperature gradient. Okay, what do you mean? If temperature increases, its resistance increases. Now you will ask me, how it will measure? I'll tell you. See, as the temperature increases, now what is happening in this coil? In this coil, we got two. Okay, so in this coil, definite amount or constant amount of current is flowing all the time. Okay, in this coil, whenever you switch on that sensor, the current will start flowing. Okay, whenever you want the temperature, it will trigger the current through this coil. Now what will happen if the voltage, now look at here, if you heat this coil or this probe, if you give the heat to this probe, what will happen? The resistance of this coil, platinum, this coil is made of platinum, will increase. So voltage, whatever voltage, here you will also get a voltage, voltmeter. Okay, so what is the formula? Voltage, current multiplied by resistance. Now current is constant, now resistance is varying. Now how it will measure the voltage or how it will measure the temperature? Let us say we will heat this coil. Now if you heat the coil, what will happen? See, this is a temperature and this is resistance. Okay, so if temperature rises, resistance will also increase. Now if resistance increases, look at here, I is constant, this is constant. Okay, now if resistance increases, voltage will definitely increase. Okay, the same principle is applied, and this is calibrated to voltage like previous thermocouple. Now voltage, if you get more voltage, more temperature. Okay, less voltage, see, then resistance will be less voltage, less temperature. That is how simply this RTD works. Now last type of sensor which was used during COVID. Okay, what is that? That is infrared. So infrared works on pyroelectric effect. So now you will ask me, what is pyroelectric effect? Pyroelectric effect means whenever, see, anything whose temperature is more than absolute zero, it will radiate the heat, and that radiated heat will be sensed by the crystals. Okay, this was established by the scientists. Now, this it, if you have seen the thermal images of humans, you will see red. Okay, so our body is emitting heat all the time. That is why we need air conditioning. Okay, in train, a lot of heat is being generated. Okay, because a lot of so many people, it will suffocate or the temperature will rise. That the reason we always radiate the heat. So that heat is measured by that gun. Okay, temperature gun. So emitted heat will come on its lens, and then lens will translate that heat to that crystal inside, and that crystal, see, there are, let's say these are crystals, then if the heat is struck on one crystal, there will be potential difference. Okay, the same principle. If there will be potential difference, that difference will be measured and we will get the temperature. Okay, the principle is same. Wherever there is a difference, temperature difference, you will get the voltage, and that voltage will be in turn converted into temperature. The figure that we will see in the next lecture. Okay, for today's lecture you understood what are the temperature sensors. Okay, thank you.